So finite sample property of the ordinary least square, we will keep using the least square because our linear regression model use a least square. So we will take a look at the classical assumptions. Assumption 1 is a linear. So everything is a linear, value times variable plus coefficient times variable plus coefficient times variable, and so on. This is error term. So it's the same, even though this is the lag, it can be a lag or other than just different variable, but still the relation should be the linear relationship. No perfect correlation, collinearity. You can have some of the collinearity, but if you have a really perfect collinearity, actually the computer has a difficulty to find the coefficient because you can have a multiple combination of the coefficient, right? So that's why we assume there's no perfect collinearity. Just a little bit of collinearity is fine, but we don't have to have we should not have a perfect linear collinearity. And zero conditional mean is also the error term should be expected error should be 0. So that's the zero conditional mean is maybe we can have a positive error, a negative error, but the expected value should be 0. We already seen the all of this assumption previously. So these two are a little bit different because this is xt and this is large X. Large X is the t x1, x2, x3, and so on. So this one is more strict. Strict means it's a strong condition. So only for this current x value against the current x value, the expected value of error should be 0. But this one is not only the current one, but all the way to the past. Still, the expected the error should be 0. That's why this is a more strict condition. But still, this is the same condition. The residual error, the mean of the residual error should be 0. Unbiasedness of the ordinary least square, the expected value of the coefficient should be the real coefficient. This is our estimation, and this is the real coefficient. And also the same variance of the residual should be the constant everywhere. Doesn't matter what is the x here. That's again the same condition we already seen. And correlation between different independent variable, that was the condition we already seen before. That's like a collinearity. But here there's another one is the autocorrelation. Autocorrelation means error in the certain time and error over another time. So T and S is different. So residual error of the time period 1 and residual error with the time period 3, that should have a 0 correlation. Yeah, in reality you cannot have a exactly 0 correlation, but correlation should be close to the 0. So why we don't have this assumption in the cross-sectional cases? We have a similar one, but we don't define the correlation of the residual. But actually we do the residual analysis and then trying to modify our model. That's why we always look for the no pattern at all. So residual supposed to be the pretty flat, no pattern. And the variable of the coefficient can be calculated this way, the sampling variance, and unbiased estimation of the error variance. If all these three 1 to 5 assumption is true, then this is true. Gauss-Markov theorem is if all the Ts to the T5 are true, then the ordinary least square estimator has a minimal variance of all linear unbiased estimator of the regression coefficient. So this is the best. Yeah, of course we don't want to have the big variance. So minimal variance is this is the most accurate. This hold condition will okay, so normal, and our error should follow the normal, and then again mean should be 0, and there is a specific standard deviation. Then standard deviation should be fixed. That's the assumption we have everywhere. The variance is not changing, so same variance. Okay, this is the kind of the inflation versus the unemployment. So if you just use this is a static model, we use the same time point, and then if you run the regression, you will have the positive. So which means it's unemployment increase, inflation increase. So it looks like this is not a trade-off. It's not suggest a trade-off. Trade-off means it's one goes up and the other one goes down, right? But if you know, according to this formula, when your unemployment goes up, inflation goes up too. So error term usually contains factor like monetary shock, income demand shock, oil price shock. Why usually this is like a shock? Because we don't model the shock. Shock is like unexpectedly happen a certain time. So when we do the regression, that's not easy to measure there is a shock or not. But that will affect the economical variable. So everything we didn't capture as a variable will be show up in the error term. Linear relationship, so we are not sure this is a linear relationship at all, right? This is restrictive, but it should be the good approximation, should be the good one. And as long as the unemployment varies over time, it's not moving the same way, not stay, we don't have to worry about the perfect collinearity here. So usually the time series data, if the certain variable is just changing, varied up and down over time, then you don't have to worry about the perfect collinearity in most of case. I will skip this part. I don't want to talk about the theory part again, but this is also same. Expected of the error should be 0 under the old unemployment, but actually the last year it can have a sign kind of the tendency, right? So when unemployment last year's unemployment goes up, then we have a less error, right? Because of all the error contains like a shocks, right? Demand shock or kind of thing. So last year's shock will affect this year's unemployment. So actually this cannot be the 0, but we assume this is a kind of 0. So it depends on the data, but you have to be careful. But our assumption is our residual should be the mean of the residual should be the 0 under the whatever the unemployment happens. So variance should be the fixed number. This is the same. And then correlation of the different time. This is we will talk about the autocorrelation here. Different time point, our residual should not have a correlation. Again, this will not be exactly the 0, but yeah, we can see. And then also the residual should be the normal. Why we keep talking about the condition? Because when we learn the regression, we don't just care about the assumption that much. But whenever we interpret our the regression result, you have to just think about is there anything, any condition can be violated significantly. Even though we said there's a lot of different assumption here, but that assumption cannot be like perfectly satisfied, right? So correlation is 0, but it will not be 0. It will be like a 0 point something. But it's not significantly big, then we can say, okay, yeah, we can assume that assumption hold. But when we have some kind of data, those assumptions, one of them is significantly violated, then all the analysis is not reliable. So that's why we do that. So this is the again the different. This is the interest rate of the 3 months treasury bill, and this is a government deficit, and then inflation and so on. So we try to find out the interest rate using the inflation and the government deficit, and you can get a pretty good model. R square is like a 60%. And also we assume that the error should be 0, but yeah, we can see this will not be exactly the 0. They will affect each other, and again the same condition you see as before. So you have to just be careful. Again, variance will not be exactly the same. They will change by the independent variable. However, they are not changing a lot, then we can just assume this is the satisfied.